All right, guys, so here we go. Today we're going to be focusing on dilations. All right, probably the most interesting of the transformations, for whatever that means. But first, I want you to recall what the one-word descriptor we used when we were doing that like transformational overview was. So remember that with the dilation, you're talking about resizing. All right, resize. All right, sometimes you also use the word scaling. Oops. Scaling. All right, now, you guys have all done that. We have like an image or something like that, and usually on the computer you'll see like that little box there, box there, box there. Sometimes, a little there, there, and there. And you can resize the image that way. Well, if you pull from a corner, it's what's called keeping the portion. Let me try that again. Keeping the proportionality of the shape. All right, just makes the whole thing bigger or smaller. All right. Whereas you can distort it if you pull from one of these tabs or these tabs. All right. Give yourself a skinnier head or, shorten something up. All right. But if you pull from a corner, it maintains the proportionality, which is a dilation. All right. Otherwise, it's something called a stretch. All right. Where it would distort the image. Dilations don't distort, they just resize or scale. All right. Now, to get all fancy, because it's important at this level of geometry that you have a better understanding of what a dilation really is. A dilation is actually, it's going to take every point, all right? A dilation actually changes the distance that each point, and it could just be 1 point, or it could be a line segment, it'd be 2 points, endpoints, or it could be a rectangle in this case, all right? It changes the distance each point is from what's called the center of dilation, according to some set scale factor. So you may have seen this picture from your geometry teacher or something like it. I imagine you probably did, or at least you should have. All right? This point right here is referred to as your center of dilation. All right? This is the, the object, this is the image. So we've been calling that the pre-image. And that, of course, is the image. So we're good. So what this did, this dilation, is it took this point right here. All right? Go to my cool pink marker here that my daughter's going to yell at me about if she sees that I took it. From the center of dilation, whatever this distance is, well, now it got pushed out here because it changed the distance each point is from the center of dilation. So now it's there. Now, if you look at that, you can probably almost eyeball it. Here it was this far away, and now it's double. All right, it doubled the distance this point was from the center of dilation, and the same would be true of each one of these. So like this point here and this point here, doubled. All right, and that's what a dilation is really doing. But from what point is critical? That center of dilation is the point that everything gets blown out from. All right, they're blown out or sometimes sucked in. All right, and we'll get to that in a minute or two. All right, so we're going to talk scale factor for a second. They typically use a scale factor with a variable of k. All right, it doesn't have to be. Some textbooks use something different. It really doesn't matter for this. All right, but this scale factor, hopefully you remember that word from, I don't know, 6th grade. All right. A factor is something that you're multiplying, right? And to scale an object. So a scale factor, that's where it's coming from. Now, this is going to be what you multiply the coordinates by. Remember, coordinates like x comma y. All right? And whatever you multiply the x by will be the exact same thing you multiply the y by. All right, super simple. But the scale factor does have an impact on what it really does to the pre-image. So, if k is greater than 1, all right, the object gets larger. Now, if I was sitting in a classroom with you, I would set you up to say, oh, well, what would make it smaller than 1? What would make it smaller, rather? And usually kids would say negative and all that. And we'll get to negative scale factors in a little bit. But no. All right. What makes a object get smaller is if your k value is between 0 and 1, like a half or a third or 2/3 or 0.9 or something like that. All right. So if you are in between 0 and 1, the object gets smaller. All right. So in other words, the image would be smaller than the pre-image. All right. Now, how it's going to be written. Capital D. We can't really deny that that looks like a 0, but it's not. All right. This is an O. All right. Like O. All right. But really, it's O for origin. All right. Because in this case, this is my center of dilation. Now, my origin does not have to be the center of dilation, but for most of what we're going to talk about today, it will be. All right, so the first thing you write that's subscripted is whatever the center of dilation is, comma, then K, which is your scale factor, like we just said. Okay? So that's how you're gonna see it as dilation centered at the origin of scale factor 5. And that's how you'll see it. Okay? Okay. Dilations, just keep tying it back to that same concept of rigid motions, are not rigid motions. There is one exception where if you could have like a dilation of scale factor -1, without getting into too much detail, that won't change the size. It will change where the points are, but it won't change the size. So you'll see questions like, which of the following is not usually? All right, and the answer is always a dilation for the exception to the rigid motion question. All right, so it's something worth storing in the memory bank there. All right, I'm going to stop there, and I'll go into the application of it next. All right, I hope that made sense. See you guys in a minute.